Greetings, members one and all of the Salivation Nation. We all know how silver has shaped our world in the world of technology, biomedical, and the like. But gold really has done so as well, but a bit quieter. And the versatility of silver is matched by none. But there is something to be said about gold in this area as well. From medicine to nanotechnology, how gold quietly shapes our world. Let's explore. This article comes to us from phys.org, and it is a very interesting article about gold. The periodic table of chemical elements turns 150 this year. The anniversary is a chance to shine a light on particular elements, some of which have seemed ubiquitous, but which ordinary people beyond the world of chemistry probably don't know much about. One of these is gold, which was a subject of the author's postgraduate degree in chemistry, and he's been studying it for almost 30 years. In chemistry, gold can be considered a late starter when compared to most other metals. It was always considered to be chemically inert, but in recent decades it has flourished and a variety of interesting applications have emerged. It has a long, curious history. It takes its name from the Latin word aurum, yellow. It is an element with a long but rather mysterious history. For instance, it's one of the 12 confirmed elements in the periodic table whose discoverer is unknown. The others are carbon, sulfur, copper, silver, iron, tin, antimony, mercury, lead, zinc, and bismuth. And it really kind of makes sense because it was discovered so long ago. How do you track who takes credit for it, or had they even known what they discovered for quite some time? Though we're not sure who discovered it, there's evidence to suggest it was known to the ancient Egyptians as far as back as 3000 BC. Historically, its primary use was for jewelry. This is still the case today. And it just goes to show you that per capita, India has the most gold. And private ownership of gold, that is. It's also used to mint coins. Gold is also found in ancient and modern art. It's used to prepare ruby and purple pigment, or as gold leaf. South Africa was once the top gold-producing country by far, and mined over 1,000 tons in 1970 alone. The annual output has steadily fallen since then. The top 3 gold-producing countries in 2017 were China, Australia, and Russia, with a combined output of almost 1,000 tons. By the way, Russia, even though it's a top-producing nation, it is accumulating more gold in its central bank coffers than they do produce. And they have a combined output of almost 1,000 tons. South Africa has dropped to 8th position, even surpassed by Peru and Indonesia. But gold's uses and its chemical properties extend into many other areas beyond jewels and minted coins. From pharmaceutical research to nanotechnology, this ancient element is being used to drive new technologies that are pushing the world of the future. But make no mistake, and I'll say this as a caveat, it does not replace silver. Now, it can be used in some places, in some applications to replace silver. In fact, in space, we use it because there's even less reaction. Silver does react with the certain elements, sulfur and the like. So, of the 118 confirmed elements in the periodic table, 9 are naturally occurring elements with radioactive isotopes that are used in so-called nuclear medicine. Gold is not radioactive, thank goodness, but it is nevertheless very useful in medicine in the form of gold-containing drugs. There are 2 classes of gold drugs used to treat rheumatoid arthritis. One is injectable gold thiolates, molecules with a sulfur atom at one end, and a chemical chain of virtually any description attached to them, found in drugs such as myocrystin, sulgonal, and allocrystin. The other is an oral complex called auranopin. Gold is also increasingly being used in nanotechnology. We actually talked about that in prior videos. A nanomaterial is generally considered a material where any of its three dimensions is 100 nanometers or less. Nanotechnology is useful because it's not restricted to a particular material. Any material could in principle be made into a nanomaterial, but rather a particular property, the property of size. For example, gold in its bulk form has a distinct yellow color, but as it is broken up into very small pieces, it starts to change color, through a range of red and purple depending on the relative size of the gold nanoparticles. Such nanoparticles could be used in a variety of applications, for example, in the biomedical or optical electronic fields. Very interesting. Another exciting advancement for gold and nanotechnology was the discovery in 1983 that a clean gold surface dipped into a solution containing a thiolate could form a self-assembled nanolayers. These monolayers. These monolayers modify the surface of gold in very innovative ways. Researchers into surface modification is important because the surface of anything can show very different properties than the bulk, that is the inside of the same material. And that is very fascinating for that kind of situation. It makes you wonder if that could be applied for minting technology to be able to provide surface modification further beyond just the laser engravings that they do now, or the very intense and detailed and intricate dyes. They may find a way to be able to color these gold coins using the gold itself. We saw before, it talked about, in this state, its smaller nano state, that it turns a variety of different colors, including magenta. Gold nanoparticles have also proven to be an effective catalyst. A catalyst is a material that increases the rate of a chemical reaction and so reduces the amount of energy required without itself undergoing any permanent chemical change. This is important because catalysis lies in the heart of many manufactured goods we use today. For example, a catalyst turns propylene into propylene oxide, which is the first step in making antifreeze. Two discoveries in the 1980s made scientists look at gold catalysts differently. Masatake Hirata in Osaka, Japan, made mixed oxides containing gold and discovered the material was remarkably active to catalyze the oxidation of toxic carbon monoxide into carbon dioxide. Today, the catalyst is found in vehicle exhaust, and we know that platinum and palladium are vying for dominance in that area. At the time, Graham Hutchings, who also worked on industry in Johannesburg, South Africa, discovered a gold catalyst that would work best for acetylene hydrochlorination. The process is central to PVC plastic, which is used in virtually all plumbing production. Until then, the industrial catalyst for this process was using environmentally unfriendly mercuric chloride material. So there's many applications, and there's others that really haven't been discovered yet. More uses that haven't been discovered yet, and more in common in the world of research. There will, in the next few years, be new developments in how the element is used, among others, medicine, nanotechnology, and catalysis. But also find new applications in relativistic quantum chemistry, combining relativistic mechanics with quantum chemistry, surface science, and I think that will be very interesting to see, luminescence and photophysics and more. Especially in the world of minting, there could be some things on the horizon from this technology and movements. Some of you may remember the video I posted a while ago where I talked about how it is used and sent into the body. These nanoparticles of gold sent into the body to kill cancer cells using radio waves, and where it melts the gold and kills off the cancer. And there's platinum is also used in that way as well. So it would be very fascinating to see how this plays out and what the future holds for gold. And in this particular case, we learned from this article that it could have an effect on fermenting technology, security features in the future for how it's displayed on the surface of these particular coins and bars and rounds. So it's very exciting what lies ahead Post your thoughts below. Would like to extend a multitude of gratitude y'all for watching, and encourage you to please rate, comment, and subscribe.